And welcome. Today's lesson is IPv4. Today we will cover learning objectives, why you need it, exercises, learning verification, and summary. Learning objectives. What is the default IPv4 MTU over Ethernet? Why does MTU matter? Why should fragmentation be avoided? What type of network activities commonly affect MTU? What is path MTU discovery? How can an IPv4 address be converted to binary? How to identify the IP address, subnet mask, and gateway from a Windows IPCONFIG output. How to find MTU and metric information on a Windows operating system. Now, why do you need it? In this case, you need Internet Protocol IP for host-to-host communication. Internet Protocol was originally designed for the Internet. The purpose of Internet Protocol is to allow packages, which is packages of bits called datagrams, to be delivered from a source to a destination across the Internet. The Internet Protocol implements two basic functions: addressing and fragmentation. Addresses are used to transmit Internet datagrams toward their destination. Fragmentation is what happens when packets are broken up and later reassembled as necessary for transmission through small packet networks. The term small here is somewhat relative. Now, routing is the term we use for selecting the path to the destination. Exercise number 1. What are the two main functions of IP? Well, as alluded to previously, the two main functions of IP are addressing and fragmentation. See, the addresses are used to transmit the Internet datagrams towards their destination. And fragmentation is what happens when the packets are broken up. And later, of course, they get reassembled as necessary for transmission through the network. Now, routing is the term we use for selecting this path that's taken to a destination. Routing will be covered in a later lesson. Exercise number 2. Now, how many bits are in an IPv4 address? There are 32 of them. Exercise number 3. What is an octet? Well, an octet is a group of 8 bits, and there are 4 of these octets in an IPv4 address, and 4 times 8 equals 32 bits. Exercise number 4. What is the default IPv4 MTU over Ethernet? Well, that is 1500. Exercise number 5. Why does MTU matter? Well, it matters because anything that's larger than that MTU has to be fragmented. MTU means maximum transmission unit. Now, think of this in the context of a FedEx delivery truck, where there's only a certain size of package that it can accept. And if the package you try to provide to FedEx is larger than this MTU, the package would have to be fragmented before it could be delivered across their delivery network. Now, the next question is exercise 6. Why should fragmentation be avoided? Well, fragmentation you should avoid it because it's going to decrease your network performance. Because you must consider that there's additional work required to repackage these packages into smaller packages. And also, you have to consider that some applications may not support this fragmentation and will fail to function. For example, there may be some things that you can't, if you try to break them down into smaller packages, they may no longer be functional. It may not even be possible to reassemble them later. And in those cases, fragmentation would just break the application. Now, what type of network activities commonly affect MTU? Exercise number 7. In this case, activities that commonly affect MTU are tunneling and encryption. And it should be noted, you can have a tunnel without encryption. Now, by tunneling, I'm actually referring to you take one package, say you're delivering it from San Antonio to New York, and you deliver it to the FedEx station. Well, they may tunnel that package for you. What they will actually do is say if it needs to go from San Antonio to New York, they might say, okay, we'll accept it from our San Antonio hub and deliver it to, say, a Buffalo, New York hub. And then from Buffalo, it then goes on to New York. But when they put it in their package, the package is addressed from San Antonio to Buffalo. And so they put it in a separate package, which gets a whole new addressing label that says destination address Buffalo from San Antonio. And that's what the package looks like, and everyone along that path only knows the outside header that says it's going from San Antonio to Buffalo. And then when it gets to Buffalo, it then opens that package up and pulls out their inner package addressed from San Antonio to New York, which gets delivered to New York. Now, what's important here to look at is when they repackage it, they still are limited by their FedEx MTU, whatever it may be. So if they then have to put another package within that package, then they may have to do fragmentation, or your package may have to be provided to them in a smaller package so it can more easily fit in their package when they tunnel it for you. Now, what is Path MTU discovery? PMTUD. Now, this is a technique that you can use to automatically discover the largest acceptable MTU for transmission along a path. Imagine that you could have a way that you could discover, hey, what's the largest package I could send through FedEx Network without them having to repackage it and then, waste their resources. And once I can figure that out, then I just always send a package of the largest acceptable size, and it will be guaranteed to have a much smoother chance of delivery. Unfortunately, Path MTU discovery is often blocked by overzealous network administrators. Exercise number 9. We're going to convert an IPv4 address to binary. In this example, the IPv4 address is 192.168.0.1. In this case, it's very simple. We take this address is shown here in a dotted decimal format, which means the different portions of the IPv4 address in decimal format are separated by dots. And the number within separated by each dot is referred to as an octet. The reason why it's referred to as an octet is because each decimal number here is translated into 8 bits, and 8 bits are an octet. And this is using the basic decimal to binary conversion that we covered in an earlier lesson. So I won't go into that here. But if you feel like you need to reassure yourself, please feel free to double check this work. But this decimal numbers translate to these binary numbers. And as you can see, we take this dotted decimal form IPv4 address and convert it out to this binary format. As you can see, each group of 8 bits octet is in the conversion. Exercise number 10. We're going to run the Windows command IPCONFIG, and we're going to try to answer the question of what the IP address is used for. In this case, we've run the IPCONFIG command on the Windows host, and there's a section in the output that says IPv4 address. And as you see here, you can see what that actual address is. You run this command on your own system, you may get a different result. But this address here on this host, which is 192.168.32.150, is the address for this host on this network. Now we look at IPCONFIG subnet mask. And we're going to run the Windows command IPCONFIG and try to figure out what the subnet mask is used for. Now in this case, we have run the IPCONFIG command again. We still see the IP address, and also we see this subnet mask here. Now the purpose of this subnet mask is for this host, when this host communicates to another host, it actually compares its own address and the subnet mask to determine to that destination address to figure out, is that destination address in the same network that I'm in? If so, I will communicate to that destination host directly. And that subnet mask is very useful for making that determination. Exercise number 12, IPCONFIG gateway. Now we're going to run the Windows command IPCONFIG and figure out what the gateway is used for. In this specific case, we see here the IPCONFIG output again, and we see a gateway address identified. Now this gateway address is actually used when this host needs to communicate with a destination, and it compares its own address and mask and realizes that destination is not on the same subnet. In this case, to get traffic to that destination, it will actually have to send to its default gateway. If you look up here, you'll see the address resolution protocol is mentioned here, and ARP and subnetting will be explained in later lessons, but they do come into play when you're looking at a scenario of communicating to other hosts. Exercise number 13, MTU and Metric. Now we're going to run a few Windows commands, ipconfig/all, as well as netsh interface IPv4 show interface. We're going to look at what does a metric mean and what does MTU mean. Here we have an output of the Windows command ipconfig/all. It gives here, shows us a host name, it gives us the description of the adapter, in this case it's local area connection, physical address, which is that Ethernet address of that adapter that we're using here. Also we see the IPv4 address, a subnet mask, information about DHCP lease, but also this default gateway, which is important. So we get a lot of user information in the output of the ipconfig/all command. Now we'll look at the output of this netsh interface IPv4 show interface command. Here we have a column for index, metric, MTU, state, and name. Name corresponds to the name of the varying interfaces on this system. We did look at the output for that local area connection, and notice the metric as well as the MTU numbers here. Now we will explain what those are. The metric refers to the preference for a path, and lower is usually better. Metric is definitely used when routing. Now, and routing will be covered in a later lesson. Now we're looking at this MTU. What does this MTU mean? Well, it's that same maximum transmission unit that we spoke of earlier. Now we're ready for our learning verification, one of two. Now, by going through this lesson, you should realize and learn these things. The two main functions of IP. How many bits there are on an IPv4 address, what an octet is, the default IPv4 MTU over Ethernet, why MTU even matters, why you should avoid fragmentation, network activities that commonly affect MTU. You should know a little bit about path MTU discovery by now. You should know how to convert an IPv4 address in dotted decimal format to binary. Within the Windows IPCONFIG output, you should be able to spot the IP address, the subnet mask, and the gateway. And within the netsh interface IPv4 show interface output, you should be able to spot the MTU and the metric. Summary. Well, to sum this lesson up, the two main functions of IP are addressing and fragmentation. There are 32 bits in an IPv4 address. An octet is a group of 8 bits, and there are 4 octets in an IPv4 address. The default IPv4 MTU over Ethernet is 1500. MTU matters because anything beyond the MTU size has to be fragmented. Fragmentation introduces a performance penalty against the network infrastructure. It is much better for the end host to send a smaller package originally than to send a too large package that the network infrastructure later has to fragment and repackage for delivery. Fragmentation should be avoided because fragmentation can greatly decrease network performance. It requires that packets be broken down and repackaged. Further, some applications may not support fragmentation and will fail to function. Network activities that commonly affect MTU are tunneling and encryption. Note that there can be tunnels without encryption. To avoid fragmentation on the network and some network performance issues that may be hard to solve otherwise, consider decreasing MTU. Path MTU discovery, PMTUD, is a technique for automatically discovering the largest acceptable MTU for transmission along a path. Unfortunately, PMTUD is often blocked by overzealous network administrators. An IP address can be converted to binary by converting each decimal octet to binary. In the Windows IPCONFIG output, the IP address is used to provide an address for the host on the network. In the Windows IPCONFIG output, the subnet mask is used by a station to compare its address to that of another station it's communicating with, and it will determine if there are other stations in the same subnet or not. If it's in the same subnet, then this station can actually send that traffic directly to that destination. Note, Address Resolution Protocol, ARP, and subnetting will be explained in later lessons. Now, looking at this default gateway thing. In the Windows IPCONFIG output, the gateway is normally used when a station needs to communicate with another station that is not in the same subnet. The station will send the traffic to its gateway and rely upon the gateway to forward the traffic to that destination. Now, this is a key concept for network operation and is why subnetting is so crucial for end-host communication. Note, the term normally is used intentionally. Please note, Address Resolution Protocol, ARP, and subnetting will be explained in later lessons. Now, we're almost done. In the Windows NetSH interface IPv4 show interface output, the MTU column displays the respective IPv4 maximum transmission unit MTU for each interface. In the Windows NetSH interface IPv4 show interface output, the metric column displays the relative preference of each interface. All things being equal, the system will prefer the interface of lower metric for communication. Note, routing will be explained in a later lesson. That concludes today's lesson. I hope it was informative. Thanks.